Routing dynamically is the process of having your router collect entries for the routing table by communicating with other routers and sending their own routing information. The main purpose of routing dynamically is to discover remote networks, maintain the latest routing information, choose the best path, and find new paths when the original ones are no longer available. In the beginning, we had Routing Information Protocol, or RIP. RIP version 1 was released in 1988 and became obsolete when RIP version 2 came out. It is rarely implemented in networks. With the need for better dynamic routing protocols, Open Shortest Path First, or OSPF, and Intermediate System to Intermediate System, or IS-IS, were created. Cisco created OSPF and two other dynamic routing protocols called Interior Gateway Routing Protocol, IGRP, and Enhanced IGRP, or EIGRP. Modern-day ISPs use a protocol called Border Gateway Protocol, or BGP. Dynamic routing protocols are used to establish and maintain networks. However, it can be more complex to implement, can be less secure, depends on the topology, and will require more router resources. This is the general idea of how a dynamic routing protocol works. The router sends and receives routing messages on the interface. The router shares routing messages and routing information with other routers. Routers exchange information to learn about remote networks. When a topology change happens, the routing protocol can tell other protocols. The router begins with a cold start, where it knows nothing about the surrounding networks. From here, the router does network discovery, where it talks to all the other routers and requests more information. Once all the routers have exchanged information and calculated their best routes, convergence is achieved. All dynamic routing protocols have their own characteristics, like purpose, operation, and behavior. Let's talk about them. Autonomous systems. IGP, EGP, and BGP are all autonomous systems. Let's talk about them for a little bit. Autonomous systems are a collection of routers under control of an organization. An autonomous system is also known as a routing domain, which are usually used by ISPs. The entirety of the internet is made up of autonomous systems. Here are some protocols that support these systems. Interior Gateway Protocol, or IGP. IGP is used to route within an autonomous system. Exterior Gateway Protocol, or EGP. EGP is used to route between one autonomous system to another. It's just like one ISP talking to another one. Border Gateway Protocol, or BGP. BGP is the only viable exterior gateway protocol at the moment. Officially used for all internet routing, most refer to EGP as BGP because of this fact. Our next protocols are distant vector routing protocols. It can be summarized based on the fact that it uses metric delay, or packet delivery time, the amount of bandwidth, the amount of link traffic, and the reliability of the link. RIP versions 1 and 2 are distance vector routing protocols. IGRP and EIGRP are also distance vector routing protocols. Let's talk more about RIP. RIP version 1 broadcasts routing updates to 255.255.255.255 every 30 seconds. It uses hop count as a metric, and a hop count greater than 15 is too far for RIP to route. In RIP version 2, it introduced support for VLSM, forwards updates to 244.0.0.9, and reduces routing entries with summarization. It also adds authentication between the routers to increase security. All RIP updates are encapsulated into UDP port 520. RIP still has a 15 hop count limitation and an administrative distance of 120. IGRP uses bandwidth, delay, load, and reliability to create its metric. Routing updates are broadcasted every 90 seconds. With EIGRP, new features and improvements were added. Some of these things include bounded trigger updates, where updates only happen when the routing table changes. Let's go ahead and review everything we've learned. The tools and control panel, Windows Action Center, User account control, Windows Update, Windows Firewall, and how firewalls work, Remote Access, BitLocker, Windows Settings. To configure RIP, you want to type router RIP into Global Configuration. If you want to get rid of RIP, just type no router RIP. Now, the next step is to advertise your locally connected networks. Simply type network followed by the network address in the router configuration mode to advertise this route. You can take a closer look at RIP by typing do show IP protocols. To check the routes, use do show IP route. If you want to enable RIP version 2, simply type version 2 in the RIP configuration mode. This makes some changes to RIP, like enabling support for VLSM. By default, RIP version 2 automatically summarizes routes. If you want to disable this, simply use the no auto summary command in RIP's configuration mode. If you don't want RIP updates going out in interface, use the passive interface command followed by the interface. You can also make all interfaces passive with the passive interface default command. If you choose to make an interface no longer passive, simply type no passive interface followed by the interface. When configuring a default route, you'll want to use the methods in episode 9, and then, in the router configuration for RIP, you'll want to use the command default information originate. To examine RIP configurations, use these commands. Our next category is link state. These routing protocols can create a complete view of topologies by gathering all sorts of information. This routing protocol uses cost as its metric. Two protocols for both of these include Open Shortest Path First and IS-IS. Both of these network protocols are known for their fast convergence and constant updates. Link state routing protocols are better for more complex routes. These protocols calculate each path to each destination with their own cost. Here's a rundown for how a link state protocol works. Each router learns about its own links and directly connected networks. Each router learns about their neighbors by exchanging hello packets. Each router builds a link state packet, or LSP, with information about each directly connected link. Each router floods the LSP to all the neighbors. Each router constructs a database and computes the best path for each network. The best part about link state algorithms is the fact that it builds its own topology, allowing faster convergence. Whenever changes happen to the network, all converged routers receive this change and reflect them on their topology. If you need to compare the routing protocols, take a look at this chart. There are all sorts of important features to the routing protocols themselves. Speed of convergence is how quickly all the routers will share information and converge. Scalability is how large the network can scale to. Use of VLSM states support for VLSM. Resource usage indicates how much resources are used for a routing protocol. Implementation and maintenance gives you an idea if a routing protocol is simple or complex. Let's talk about the types of routes you will encounter within the routing table. Ultimate route. Routing table entries that contain either a next hop IPv4 address or an exit interface. Directly connected, dynamically learned, and local routes are ultimate routes. Level 1 route. A level 1 route is a route with a subnet mask equal to or less than a classful mask of a network address. Ultimate routes can also be level 1 routes. A level 1 route can also be a network route, a route that has a subnet mask equal to that of a classful network. Supernet route. A route that is a network address with a subnet mask less than a classful mask, like a summary address. A default route. A default route is a static route with an address of 0.0.0.0 with a prefix of 0. Level 1 parent route. A level 1 parent route is a level 1 network route that has been subnetted. A parent route can never be an ultimate route. Usually, if one network address says that it has been variably subnetted within a routing table, then it is a level 1 parent route. Level 2 child route. A level 2 child route is derived from a parent route being subnetted. So how does a router process router lookups? Take a look at this chart to get an idea of how a router makes its decisions. That's it for this episode. In the next one, we're going to talk about ACLs.